All right, good morning, you guys. I had a question come in about control charts and looking at what would it look like when the mean is increasing versus decreasing, and then same with standard deviation. So with a mean that's increasing, so keep in mind that right here, here's my center line. Let me highlight that in red right there. That's my center line in both of these scenarios. So if I'm looking at a mean that is increasing, that means that the bulk of my data is above the center line, or at least it doesn't have to be the bulk of it, but it has to be more than what is on the other side. So here we're saying, okay, let's say that I have a piece that starts right at the center line, and then I have a piece above, a few above, maybe I'll have a few below. Right now I'm seeing it kind of average out. Right, I'm not seeing an increase just yet, but if I put the rest of my data just on one side and I have a lot of weight, some values that are pretty large up in here, kind of like this would signal to me that there has been a shift in the mean. So it just means I need more data, right? It doesn't have to be super dramatic, but I need to have more data on the upper side of that center line for the mean to increase, okay? For it to decrease, I'm seeing the same thing, but on the opposite side of the center line. So I could have a system that has started off, maybe I'm starting off at the center line, and then I'm kind of creeping below, maybe it creeps above. And right now it's kind of balancing out, right? It's kind of stabilizing. It would average at where that center line is. But then I'm gonna have maybe a concentration that is on that lower side, which would signal to me a shift of mean. The bulk or the majority of my data is below the center line. So indicating that there has been a shift downward in the overall average. So mean is an overall average, right? It's looking at it like how does it balance out, right? That center line should be that balance point, right? So if we see a concentration of data above the center line, that indicates that the mean is shifting upward. And if we see a concentration below it, then it's shifting downward. Okay, and then I'm going to do the same thing looking at standard deviation. So standard deviation, right, we're looking at how much variation there is in relation to the mean itself. So we expect some natural variation in our data points, and we know that, well, 68% of the time we expect our data to be within plus or minus 1 standard deviation of the mean, 95% of the time within plus or minus 2, and then 99.7% of the time within plus or minus 3 standard deviations. So if I'm looking at something that seems pretty stable, right, I have a data point here, I'm still in that C zone, so I'm within 1 standard deviation. Maybe I pop into B a little bit, kind of like that. This seems okay so far, right? If I connect my dots, this looks like the standard deviation is staying pretty stable, right? Most of it is in that C range. I got a couple in the B. And if I want to show that it's increasing, that just means I'm seeing more variation. So I'm seeing more fluctuation in my data points. So maybe I have a point that's down here in A, and then I have a point that's, you know, over here in B, like that, and then maybe up here in A, and then down here in B, kind of like this. So I'm seeing that the data is becoming more spread out about the mean. Okay, so something like that would indicate that my standard deviation has increased. There is more variation than I would expect if everything was in control. So here I think I have about room for about 15 observations. So in 15 observations, if I'm thinking about 68% of them, I would expect maybe roughly 10 of them to be in that C zone. And then maybe I would expect about 4 of them to be in the B zone, but I'm seeing more and more in the A zone. So I'm seeing more variation than I should, which indicates that my standard deviation is increasing. Right? My product, whatever I'm pumping out, is not as consistent as it was initially when we set these markers. Okay, if I'm looking at a standard deviation that is decreasing, so we're seeing that there is less variation than we would have expected. That would be something where maybe I'm seeing all of my data in the C zone, for example. So let me plot a few observations like this. Right, so I'm seeing that my data is more tightly packed around the mean, right, which I expect. 68% of the time I expect that. That's not shocking to me. But I'm not seeing anything right now that's even in zone B or A. So let's say I just stop like that. I can see that my data is much more packed together around the mean, right? More concentrated, more consistent than when we initially set our mean and standard deviation. So this would be an indication that the standard deviation has decreased. So again, standard deviation, we're just interested in how spread out our data is in relation to the mean, right? It's a measure of variability. How much variation are we seeing? Are we seeing an increase in variation? Do we see that our data points are fluctuating more dramatically here around the mean? Or are we seeing that things are tightening up and it's much more consistent and packed and concentrated around the mean like we're seeing right here? All right, I hope that helps you visualize what a change in mean versus standard deviation would look like. Have a wonderful rest of your day.